Hello wonderful person, this is Anton, and in this video we're going to be discussing a cosmic mystery that's been hiding in plain sight for a very long time, and specifically hiding in the center of our own galaxy, the Milky Way. And that's because for decades astronomers believed that this object, referred to as Terzan 5, and that's been captured by telescopes like Hubble many times, was your typical standard globular cluster that was just a little bit too dusty. And I'm going to explain what globular clusters usually are in just a few seconds. But the new data from the James Webb Space Telescope revealed that this seems to be not the case, with the new suggestion being that this is something a lot more rare and actually far more important for our understanding of how Milky Way formed and how objects similar to this seem to have evolved over time. But first, let's briefly discuss what we know about Terzan 5 already and what a typical globular cluster is. Now first, as you can see from this video, it's located inside the galactic bulge, basically the central spherical region of the Milky Way that seems to be crowded with a lot of ancient stars. And it is a very difficult place to study because it contains a lot of gas and a lot of dust. In fact, it's so hard to study that this object was only found in 1968 by the French astronomer Auguste Terzan, which is why it's called Terzan 5. And since then, pretty much until now, this was classified as a globular cluster. But what is a globular cluster? Well, by definition, these are ancient balls of stars, very often containing hundreds of thousands or even millions of stars, packed in a relatively tight formation. And so, in some sense, they look something like this. They are sometimes also referred to as stars made out of stars. And in most cases, these are some of the oldest objects in the universe, typically 10 to 13 billion years old, because the majority of them seem to have been created around this time. Now, there's actually still a bit of a mystery on how they were created, or basically what caused them to be formed. But because most galaxies seem to contain them, today they're actually usually used as a kind of a natural laboratory to study galactic evolution, and to also study how stars evolve and how galaxies first came together. And that's because normally, even in a distant galaxy, it's actually pretty easy to count how many globular clusters they seem to contain, and to then use this to calculate a lot of different properties about this particular galaxy, including how many collisions it potentially experienced. More globular clusters means more collisions. But traditionally, we actually thought that every star in a typical globular cluster was a kind of a sibling, meaning that they all formed at the same time, and very likely from the same gas cloud that suddenly collapsed and caused these stars to form in a very short period of time. But pretty early on, it was discovered that Terzan 5 seems to be special. It seems to not follow the same rules. And so back in 2009, scientists studying this particular globular cluster discovered that it seems to contain two separate generations of stars. One group was approximately 12 billion years old, but the other one was only 5 billion years old, implying that there was at least 7 billion years between their formation, which was already pretty strange and was already pretty difficult to explain. But this recent study that used some of the observations from the James Webb made things even a little bit more interesting and unusual. Because here in this new study by Zulo and the team you see on the screen, scientists used the infrared observations to measure the proper motion of different stars over time. Or to be more exact, they basically separated stars that belong to Terzan 5 from the stars in the background, and then measured how they were moving compared to each other, which revealed that Terzan 5 seems to have 4 distinct generations of stars, with stars forming 12.5 billion years ago, 4.7, 3.8, and 2.5 billion years ago, which basically makes Terzan 5 not a globular cluster at all, but instead what astronomers are now calling a bulge fossil fragment, essentially a kind of a new type of an object. And so here, billions of years ago, the Milky Way's bulge formed when a lot of these massive clumps of stars merged together. And it's quite likely that initially Terzan 5 was also one of these chunks that was supposed to merge and result in the bulge itself. So it was a kind of a primordial building block. But for some reason it survived and was not destroyed for billions and billions of years. Most likely because it was just massive enough to sort of create its own structure. Here it contained approximately 2 million solar masses. And so it was able to hold on to the gas and to some of the first stars which allowed it to basically create its own miniature ecosystem with 4 separate birth formation periods from all of this gas that was captured when the bulge was forming. And so over several billion years, it was able to form new stars 4 separate times. And by itself, this is actually a really intriguing and unexpected discovery that dramatically changes our understanding of what exactly some globular clusters potentially are and how galaxies seem to evolve as well. Because first of all, this confirms that galaxies like our own very likely formed from a lot of these clumpy structures that merged over time. As a matter of fact, James Webb Space Telescope has already found quite a few of these clumpy structures in the very early universe billions of years ago. One example in this case is the famous Firefly Sparkle galaxy. We've talked about this object in one of the videos in the description approximately 2 years ago. And what looks like at least one of these chunks, or one of these fossils, remained in our galaxy for billions of years, and technically now allows us to study some of these ancient galactic formation processes right here in the Milky Way galaxy. But importantly, Terzan 5 is not even the only weird object that was recently discovered when it comes to globular clusters. Because in the last few years, our understanding of these strange objects has been overturned multiple times. For example, this object, Liller 1, has now also been identified as this potential bulge fossil fragment because it also seems to contain multiple generations of stars, implying that Terzan 5 is not the only such object. But initially, this was kind of difficult to explain until it was finally confirmed that Terzan 5 seems to be very similar, with other globular clusters like 47 Tucanae that you see right here, revealing completely different mysteries that are also difficult to explain. For example, here, by conducting radio observations of this cluster, researchers discovered a mysterious signal in its center, and it's not entirely clear what's actually causing this. And though this obviously could be some kind of a strange black hole or some kind of a strange pulsar, such as for example a rare intermediate mass black hole, right now nobody has any idea what this object is. It is essentially a mysterious radio signal in a location where we don't really expect it. This was discussed in this study you can find in the description. With additional studies studying populations of stars in various other clusters, essentially discovering that quite a few of them seem to evolve over time and sometimes do contain multiple stellar populations, basically a primordial one from the first formation and some kind of a second population involving anomalous chemical abundances, implying that at least a few globular clusters very likely had multiple star-forming episodes because they contain a lot of gas inside. And some clusters, like this one here, VVV-CL002, seems to also have very unusual orbits, and in this case seems to be actually plunging into the center of the Milky Way, in this case moving pretty fast at 400 km per second, which means that it possibly came from somewhere else and is now potentially doomed because at some point it will probably be destroyed by the tidal forces very close to the central black hole. But exactly where it came from is currently unknown. But even since their initial discovery in the 17th century, these objects are still kind of poorly understood. Because, for example, unlike galaxies, these massive collections of stars seem to show no signs of dark matter and seem to usually exhibit striking uniformity and chemical composition inside their stars, which basically means that we don't really understand how most of them were formed and why they ended up being so perfectly spherical. And on top of this, based on some of the supercomputer simulations, in this case using something known as EDGE or Evolution of Diverse Galaxies and Environments, researchers have also discovered a potentially new type of an object referred to as globular cluster-like dwarfs. Basically objects that resemble globular clusters, but unlike real clusters, seem to also contain a halo of dark matter. Although in this case this is just based on simulations and no such object has been actually discovered for now. But if we can find these in the real world, it would give us a perfect way to study what dark matter actually is and maybe even discover the actual particle. Right now though, there's maybe just one candidate that's been discovered so far. A tiny dwarf galaxy that's barely visible in this image, referred to as Reticulum 2. An object that actually resembles a globular cluster, but that also seems to contain its own dark matter. And well, in the end, what does all of this tell us about the universe and of course galactic formation? Well, it does tell us that the universe is generally much more complex than we initially thought. and of course compared to anything we've read in some of the older textbooks. And that's because we actually thought that globular clusters were some of the simpler objects out there and possibly represented some kind of an ancient galactic leftover. But we now see them as something way more dynamic and way more complex that seems to also evolve over time, and something that even seems to maybe contain black holes and dark matter somewhere inside. And though technically we still see them as these last surviving seeds of galactic formation, even today, as of 2026, it's not entirely clear how they were formed. But by studying these objects in more detail and trying to understand objects like Terzan 5, we can now get a slightly more clear picture on how galaxies potentially formed, and how sometimes not everything merged with the galaxy, with some remnants forming their own structures. With these new studies being a reminder that even in our own galaxy, there are still quite a lot of mysterious objects, and objects that potentially might teach us more about how everything in the universe started. But right now, in the next few years, the same researchers from the University of Bologna are going to be looking at 50 more globular clusters in order to see if maybe some of them are also these bizarre fragments, or these hidden fossil fragments left from the early Milky Way. Which means that we'll come back and talk more about this once there are some additional discoveries. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.